In this topic 4, let's continue with the second panel data model, that is fixed effects. Before we proceed to the command, you have to know there are two ways to do fixed effect estimation. The first one is least square dummy variable, LSDV. It means that we are going to create a dummy variable for each cross-sectional units in the data. This dummy variable is meant to capture the unobserved heterogeneity factor, hence producing an unbiased OLS estimate. Let's head over to Stata and run this command. Now we write the command here, regress y x1 I dot country. I dot country here is to tell Stata to create dummy variable for each country. You can change the word country here to any name of the cross-sectional identifier variable in your own data set. So let's press enter, and here is the result, the identical result that you saw in the slide just now. Let's go back to the slide. Firstly, note here, there are specific intercepts or coefficient for the country dummies. But we don't see Australia as the first country in the sample because the base dummy here is meant for the first country, which is Australia. From the result, we can clearly see that in least square dummy variable estimation, the coefficient for x1 is 2.48. Just a side note here, I just mentioned the number that is shown here, 2.48, because it is in scientific notation with plus sign. That makes its actual value way bigger than 2.48. But let's just focus on the number only. And this coefficient size 2.48 is apparently smaller than that of pole OLS that we estimated earlier, which is 4.96. Why LSDV gives different result than pole OLS? Okay, this is the explanation about the model, the least square dummy variable model that we just did. Originally, we have this equation, but in least square dummy variable, we assume that in the error term, there is unobserved heterogeneity factor by the notation of VI. And this VI is reflecting the unobserved characteristic of the panel units. Then we incorporate the equation 2 into equation 1 by creating dummy variable for each country. Then we estimate OLS for this model. By adding a dummy variable for each country, it means that we allow different intercepts for different countries. Hence, the whole idea about LSDV is that we capture and control the heterogeneity factor in the error term via dummy variable for each country, eventually leading to better estimates of the coefficient of regressor x1. Just now we know that the coefficient for x1 is 2.48. So it reflects the slope of the relationship between x1 and y. And the slope is applicable for all countries, or we call it homogeneous slope. But the problem in LSDV variable is that it is only feasible for a small number of cross-sectional units n in our sample. If we have big number of n, let's say big number of countries or firms or persons, more than 100, for example, so the LSDV model will be problematic because there will be so many dummy variables, and therefore it will reduce the degree of freedom of this estimation. So let's now see the visual comparison between LSDV and pool OLS estimation. So you can copy this command and put into Stata. Predict y hat is to predict the y value from the LSDV estimation. And then we separate the predicted y according to countries. And then we do a two-way graph, and we connect all the y hat 1 until y hat 7, the specific country predicted y. We plot against the x1, the regressor, And then here we also create the fitted line for the OLS, pool OLS, y by the y against x1, and then make it thicker to segregate or to separate between the OLS fitted line and the LSDV fitted line. From this graph, we can clearly see the lines with dots here are the individual countries' fitted line for LSDV model. And these fitted lines apparently have different intercept. So if you extend these lines to the y-axis, you can see each of the 7 fitted lines have different intercepts. It means that in LSDV, we allow unique characteristic between countries or the unobserved heterogeneity in the model to exist, and we capture via different dummy variable. And therefore, we get the much steeper slope of these fitted lines. And we compare these fitted lines of LSDV to the fitted line of OLS, pool OLS here. So we know that this pool OLS fitted line is much less steep, indicating the incorrect estimates of the relationship between x1 and y if we ignore the presence of unobserved heterogeneity factor.